Okay, again, we have these two equations. We're going to solve these equations by elimination. Now, I've somewhat clumsily numbered these equations, and I'll do this a little more slowly in another video in case you need it, where I spread things out a little more than I did on this board here. But what we do for elimination is we eliminate one variable or another, and the way we're going to do that is we're going to keep the first equation as it is. But the second equation is going to be changed. If we add double the first equation to this, if we add -2 times the first equation to the second equation, we're going to get an equation where x is no longer present. That's because, and you can see here, if we multiply -2, the circle around the 1 means the first equation. -2 times the first equation is going to give us what? -2 times 2x is -4x, -2 times 3y is -6y, -2 times 8 is -16. So -2 times the first equation is -4x minus 6y equals 16. We add that to the second equation, 4x minus 2y equals 0, which I repeat here, directly under the -2 times the first equation. So that when I add the x terms here, I have -4x and 4x, that's going to give me 0. I have -6y and -2y, that's going to give me -8y. I have -16 and 0, well, that gives me -16. And I went ahead and wrote down the clear solution to this is y equals 2, but that's not really part of the process that I'm going to do over here. Actually, it is, but we're going to address that separately. Okay, so what we've done is we've added -2 times the first equation to the second equation. That's with the -2 times 1 plus 2, with the 1 and the 2 circled, so we know that they refer to the equations 1 and 2 in the previous step. And what we then have is we have the first equation, as I said, and we have the second equation now is -8y equals -16. Okay, at this stage we could proceed to solve the system because we know that -8y minus equals -16 has solution y equals 2. That's very straightforward. And so we know that y is going to be 2. We know that whatever values x and y satisfy the equation, the y value has to be 2. We can take that y value 2 and plug it back into either equation, either of our original equations, and solve for x. And we're going to get x equals 1. So that we know that our solution now is 1, 2. Okay, now what I just did is what we'd call back substitution. We can rewrite the system this way, so that we've got an explicit solution for y. We can plug that value of y in and solve the equation for x, and we get x equals 1. Now there's a more formal way to accomplish this. So we've implicitly seen that we can add a multiple of one row to another and replace either row by that sum. We use that to get the second equation into this form. I want to do this just by operations on single equations, so what I'll do here is, okay, here are my original two equations, here are my two equations after one step. In the next step, we leave the first equation as it is, and we divide the second equation by -8. In other words, we multiply it by -1/8 if you prefer. And if we divide this by -8 or multiply by -1/8, obviously we get y equals 2, we know that. So we've applied now a rule that says I can multiply an equation by any constant number. And of course, since division is just multiplication by a reciprocal, it means I can divide by any number as long as I'm not dividing by 0. Okay, so now we got 2x plus 3y equals 8, y equals 2. I skipped to the solution x equals 1, y equals 2, but the way that would be accomplished by formal operations would be that we would add -3 times this equation to this equation. And then we would, that would give us a 0 here. So we just have 2x, we'd have 2x equals 2, then we'd multiply this equation by 1/2. Now I'm going to write these equations out in more detail and show that process. But first, in the very next video, I'm going to talk about what I did here briefly, and then I'll write it out more clearly on a board and spread it out so that you can really see what's going on.